Delete an element from min-heap. Suppose this min-heap is given and we want to delete an element, but which element we want to delete? It is not given. So as usual we have seen in the last lecture also, so we will take the last one, the rightmost element we will take and we will shift it or we will delete it, because we cannot delete root element in min-heap directly because this is the minimum element, so we cannot delete it like this. So what we need to do, suppose if here the rightmost element is 80, so what we need to do, what we will do here, we will delete this 80. So first what will happen, if we delete this one, then it will shift to this side. So what will happen, 80 will, this is we are going to delete this, the rightmost element, so we will shift it here. So 80 will come here, then 70 is there, where it will shift here to its roots. So 70 will come here and 70 will come here, then 30 is there, then what will happen, then 30 will shift to its roots, that is 20, then 30 will come here, then 20 is here, then what will happen, 20 will shift to its root, that is 10, so 20 will come here, now 10 will get deleted because this is a root element and it will get deleted. So in that way we can delete an element that is the root element of the min-heap. Then what will be the tree, we can see the tree from here. So tree will be like that, initially it was 10, so now it will be 20, and here what it will be 30, and here what it will be 50 as before. Now what it will be 40 as usual before. Left child and right child, what it will be 70, and here as it remains same, 60 and 70, and 40 child, 50 and 60 will remain same, so we will write here 50 and 60. But what will come here, 80 will come, and the place where 80 was there were before, it get empty, so we can say like this. So this element get deleted, or we can say this element get deleted but this element get shifted from there to here. So here it is 80 and it shifted to there, so 70, and it shifted to its roots, that is 30, and 30 shifted to its root, that is 20, so we can delete the root element. So in the similar way, how we can write the same thing in the form of array, so we can write all these things in the form of array also. So first this tree, so we'll start from 10, so we'll write 10, then it's childs 20 and 50, then 20 childs are 40 and 30, then 50 childs are 60 and 70, then 40 childs are 50 and 60, and then 30 childs are 70 and 80. Now we'll do indexing. So 1 2 3 4 5 6 7 8 9 10 11, just like that. And we want to delete an element, so like rightmost element we want to delete, so we can say simply the 10th we want to delete this element, so we are not supposing this element, so we are deleting from there to here. So its root is 10 parent is 5, 10 parent is 5, so we are shifting simply this we want to delete 80, we want to delete, so we are shifting 80 here, and its parent, that is 10th index, so its parent is 5, so we are shifting this element there to here, so 70 will come here, and 30 is there. So 30 parent is so its parent is 2, because 4 and 5th are the child of second index, so its parent is this. So 30 will shift here, and its parent is 1, so it will shift here. 20 will shift here, 20 will shift here. So after that we can say simply what will be the it will be, instead of 10 what will come, 20, and instead of 20 what will come, 30, and then 50, 40 will remain same, and instead of 30 what will come, 70, and 60 and 70 will remain same, then 50 and 60 will remain same, and instead of 70 what will come, 80. So in this way it will see in the form of array. So we can do indexing now. 1 2 3 4 5 6 7 8 9 10. So initially there were 11 elements, now there are 10 elements after deletion of one element. So this is the way of deleting the element from the min heap when element is not given. So we delete always from right to rightmost element, and we shift it to its parents, towards parents, and in that way we can delete the root element from the min heap.